So the first function that we're going to focus on, we're going to look at quadratic functions. And we'll start with this one because hopefully it's a review. So parabolas are also called quadratic functions. I go over this with students a lot. So a linear relation or a linear function creates a line on a graph, and a quadratic function creates a parabola on a graph. So it's just the shape. We call this a parabola. Consider a model rocket that's fired straight up into the air. The graph of the height of this rocket at any time is a parabola similar to the one shown. So if we fire a rocket up into the air, it goes up to a maximum height. There's a peak here called the vertex, and then it starts to fall. So sometimes we have x-axis and a y-axis. Other times when we're talking about an actual real life problem, maybe this axis represents height and this axis represents time. So the standard form of a quadratic, what you'll notice is that you'll have numerical coefficients and a constant at the end most often, but the highest exponent you see is a 2, and that's how we know that it's actually not a straight line, it's a quadratic. When we look at vertex form is written in a different way. It is the exact same equation, but written so that we're able to see what the vertex is. So the vertex here would be PQ. Also in grade 10, you might remember talking about the simplest quadratic function, which is y equals x squared. That is our parent function or our root function. So first, let's just look at that, because in order to make transformations, which is what this unit is about, we have to remember how to graph this simplest quadratic function. So we can start with values -3 for x, -2. Maybe we only need to start with -2, -1, but we'll have -3 in there as well. So some values here that you can use whenever we're working with quadratic functions. When you sub in -3 for x, -3 times -3 is 9. And when I sub in -2 for x, -2 times -2 is 4. -1 times -1 is 1. So this is how we would fill in our values for y, by subbing into our equation 1 times 1, 2 times 2, and 3 times 3. So our basic parent function, we have a vertex at 0, 0, and you might remember this pattern. We go over 1 and up 1 in both directions. So that's this point here, -1, 1. We go over 1 and up 1 on the right as well. So that's this point here, 1, 1. From the vertex, we go over 2 and up 4. This is our pattern, over 2 and up 4. So hopefully this is familiar. That is those 2 points here as well. And then from the vertex, if we have room, we'd go over 3 and up 9. So this graph isn't big enough, so we don't necessarily have to have the 3's. We see the shape here, and we know that it continues on, so we put arrows at the end. This is our original root function, y equals x squared, or we could say f of x equals x squared. So remember that pattern, from the vertex, over 1 up 1, both sides, over 2 up 4. I often will say this again and again, over 1 up 1, over 2 up 4. This is our pattern. This is how far over we go, and this is how far up or down we go. So this is kind of our x, and this is our y. So in grade 10 math, you spend a lot of time trying to avoid this table of values and be able to just graph these parabolas just with using this pattern that we just talked about. We've reviewed domain and range a little bit. So if we have a vertex of 0, 0, that's our point here. For the domain, we're looking at, okay, where will this graph go? Where will this parabola, how will it cover our x-axis? And as this parabola continues, it gets wider and wider as it goes. So eventually it's going to cover all of the values to the left and all of the values to the right. So for any quadratic, we say the domain is x such that x is an element of all real numbers. The range is a little bit different because for this one, the lowest point here vertically is at 0. So this parabola is going to only cover values for y that are from 0 and up. So our range, we'd say the set of y, such that y is anything greater than or equal to 0, and y is an element of all real numbers. We also can talk about an axis of symmetry. Remember that an axis of symmetry is the kind of like the fold line down the center. Axis of symmetry for this parabola is x equals 0. The equation for our axis of symmetry is x equals 0. What else? This might be also something you might see. This is considered a minimum for this graph because the vertex is at the bottom of the graph. If you had a parabola that went in this direction, the vertex would be a maximum because it would be at the top of the graph. So the axis of symmetry is a vertical line through the vertex of the parabola. A couple of more things that we should probably review. This is often the formula that I use when I'm teaching grade 10 math. So I have my vertical stretch or compression, my horizontal translation, and my vertical translation. So this is meant to be a little bit of review here down below, but don't worry, we'll go over these steps. In grade 11, we might be using different variables for this. You might see something like this for a quadratic equation with C's and D's, but please know that the variables don't really matter. Whatever variables are used in each equation, it means the same thing. The only thing we might add that I usually don't do in grade 10, we might be adding in here a horizontal stretch or compression in grade 11, which I usually don't do that at all in grade 10 math, and I'm not sure if you've done that before. So this is a typical question that you would have seen before. When you have brackets in an equation for a quadratic, it means that this is your horizontal translation number. And remember, this in the brackets is always the opposite direction. So this is telling you to move your parabola 3 units to the right. So if you can remember our pattern from the front, we are going to go over 1 and up 1 and over 2 and up 4. Remember, f of x just takes the place of y, so this shouldn't make much of a difference to you. I would rather see this written in vertex form the way that I like to see it, so I want the +3 at the back. When you have a constant number like that, that is your vertical translation, and +3 means you'd move up 3. +4 means that you would go left 4. This parabola actually opens down because of the negative, and the 2 means that it's actually vertically stretched. So you might remember that I would go left 4 and up 3 first. 1, 2, 3, 4 and up 1, 2, 3. That is my vertex. So my vertex is -4, 3 because I always go in the opposite direction as what is inside the brackets. This parabola is upside down, so I know that my pattern, I'm going to go over 1, but I'm going to go down from there. But the thing is, 1, 1, 2, 4 is always our pattern. But when you have a number here, we actually have to multiply these numbers by 2. You could multiply by -2 if you want. It just means we have to go down 2 and down 8 instead. This is vertically stretched. I don't go over 1 and down 1. I go over 1 and down 2 on both sides because it's stretched by a factor of 2. I go down twice as far. I don't go over 2 and down 4. I go over 2 and down 8. So hopefully that's a little bit of review for you. So in general, the graph of a quadratic function is given in vertex form. This is the most helpful form for us because vertex form helps us see exactly how to graph it. So the graph, if we want a graph, vertex form is excellent for that. If a is greater than 0, the parabola opens up. If a is less than 0, the parabola opens down. So this next one, state the direction of opening, the coordinates of the vertex, and the axis of symmetry, the domain and range of this function. So maybe we don't even have to graph this. The direction of opening, so I see the negative right after the equal sign, so I know this opens down. That's where your negative sign will always be. The vertex, I have to remember that this actually means right 5 and down 4. So my vertex is 5, negative 4. The axis of symmetry, usually that's the equation of the axis of symmetry. That would be the middle line of our parabola. And because we have to go sideways 5, the middle line would be at x equals 5. The domain for a quadratic is always x such that x is an element of all real numbers. And then the range might be a little confusing. I know that this parabola opens down, so it's going in this direction. I know that if I go right 5 and down 4, this is going to be the highest point at negative 4. So the range is going to be the set of y such that y is anything less than or equal to negative 4, and y is an element of all real numbers. Okay, so definitely a grade 11 question here. I see a lot of the same values that we've been talking about, except I've thrown in a horizontal stretch. So this here, because it's a fraction, this is a vertical stretch by a factor of 2. This is actually, when it's a fraction, it's actually a horizontal stretch by a factor of 4. So it's going to be hard to remember that. The horizontal stretch is always the opposite of what you see. So if I see a quarter, it's actually a stretch. If I see a number in there like 4, it's going to be a compression. I also know that I'm going to go right 3 and up 5. So that's the y is going to go up 5. The x is going to go right 3. So we just need a few points. This is our original parent function. What we're going to do first is, often we start with the brackets. We might start with our horizontal stretch or compression. Then we definitely still move to the multiplication that is the vertical stretch. Then we'd move to addition or subtraction, which would be your horizontal and vertical translations. So if I take these original points, and I think that this is a horizontal stretch by a factor of 4, I have to multiply the x's by 4. So if I multiply all my x values here by 4, I get negative 8, negative 4, 0, 4, and 8. My y values are going to stay the same for now. Although you could have done both of these at the same time if you want to save some time. If I have a vertical stretch by a factor of 2, vertical stretch, I'm going to have to multiply my y's by 2. So if I look at my points, my original points, I'm going to take all of my y's and multiply them by 2. So 4 becomes 8, 1 becomes 2, 0 is still 0, 1 becomes 2, and 4 times 2 is 8. So I also could have multiplied by negative 2. I could have multiplied by y's by negative 2 because there is a reflection in the x-axis. So remember, if there's a reflection in the x-axis along your x-axis, if your parabola was up here, it becomes down here. The y values are affected and they become negative. So I think you probably could have done those 3 steps in one column. I'm just trying to really break it down slowly so that you can understand where the numbers are coming from. But yeah, I could probably just deal with my x values and my y values and flip the signs of the y values all at once. And then sometimes we do both of these translations at the same time. So this means we're going to have to add 3 to x, and we're going to have to add 5 to y. So this is no longer multiplication. We've changed to addition here, or subtraction sometimes. So if I have to add 3 to x, I would just go down, and I usually just do my x's at the same time because I can keep it straight what I'm doing. I'm adding 3. And then I do all of my y's at the same time, just because I can keep it a little bit straighter in my head. I'm going to add 5 to all of my y's. So I end up with a set of ordered pairs. I'm going to graph the parent function on here as well. So my new points, -5, -3, and -1, 3, 3, 5. And the domain of this new function is the set of x, such that x is an element of all real numbers. Just all of the numbers along the x-axis, and the range, our highest point here is 5. So the range is the set of y such that y is anything less than or equal to 5 because it's opening down, and y is an element of all real numbers.